Now that we have successfully generated a .xsa hardware platform file, we can move on to Vitis tutorial and use the instructions given to import the hardware file and build the PL LED Blinky software application on top of it. The steps for the Vitis tutorial can be broadly categorized as follows. Create a Vitis platform project, create a baseline Hello World application project, JTAG setup of OSDZU3-REF development platform, run Hello World application on OSDZU3-REF development platform to validate the setup, replace the source code of the Hello World project with PL LED Blinky code, rebuild and run the application on OSDZU3-REF development platform. Let's go to octavosystems.com. Under products, go to OSDZU3-REF product page. Under application notes, click on OSDZU3 Vitis tutorial. All the steps we'll be following in this video are directly pulled from this tutorial. As part of tutorial requirements, download and install the version of Vitis recommended under section 3.1 of the Vitis tutorial. Today, I'll be using version 2021.2. The download requires Xilinx login and the installation takes about an hour. To save time, I've already installed Vitis on my system. Next, download the sample code files using the link provided. The downloaded file is called OSDZU3 tutorial files version 1.zip. Unzip the file once you download it so that it becomes easier to use later. Next, create a Vitis workspace directory. I'll create a directory named Vitis_workspace under my home directory. Launch a new terminal from your Vitis workspace directory. Open Vitis by sourcing settings.sh from your Vitis installation directory and then use Vitis command to open the GUI. In my case, it is source tools Xilinx Vitis 2021.2 settings64.sh and then the Vitis command. Vitis brings up Vitis IDE launcher window and asks you to select a directory as workspace. Browse and choose the Vitis_workspace directory we just created. Press launch to launch Vitis in the chosen workspace. Next, let's create OSDZU3-REF Vitis platform project. Click on File, then New, and then select Platform Project. Give the name as OSDZU3-REF_PL_LED_PFM for platform. Click Next. Under Create a new platform from Hardware tab, click on Browse and open the OSDZU3-REF PL_LED hardware.xsa file we exported from Vivado as part of previous steps. Once the file opens, make sure the operating system is standalone, processor is PSU_Cortex A53_0, and architecture is 64-bit. Check the Generate Boot Components checkbox and ensure the target processor for FSPL is PSU_Cortex A53_0. Click Finish to generate the Vitis hardware platform. It should now be visible under Explorer. Right-click on OSDZU3-REF PL_LED platform under Explorer window. Click Build. Once the build finishes, under OSDZU3 platform project, open platform.spr file. Under Zynq MP_FSPL domain, choose board support package and then click Modify BSP settings. Under standalone, ensure both STD-in and STD-out are set to PSU UART 0. Similarly, verify STD-in and STD-out for standalone on PSU Cortex A53_0 domain as well. Next, let's create a baseline Hello World software application. From the Vitis toolbar, select File, click on New, choose Application Project. When the New Application Project dialog appears, click Next. Under Select a New Platform from Repository tab, choose OSDZU3-REF PL LED platform, Vitis platform already created as part of previous section. Click Next. In the Application Project Details window, select the project name as PL LED Blinky. All these settings can be left as defaults. Click Next. The domain window lets you choose the domain for the application project. You should see standalone on PSU Cortex A53 0 automatically selected. Click Next. Under Templates, choose Hello World and press Finish. You should now see PL LED Blinky application project under Explorer. Right click on the project and click Build Project to build it. At this point, the application project can only output Hello World to the UART console since it was built using Hello World template. Let's use the Hello World output to validate our board setup and UART console before moving forward to blink the PL LEDs. Once the application project is built successfully, let's move on to the JTAG setup of the OSDZU3-REF development platform so that we can run the application on hardware. To prepare the OSDZU3-REF development platform in JTAG mode, connect a micro USB to USB-A cable between the JTAG programming module on the OSDZU3 reference board and your host computer running Vitis. Select the boot mode to PS JTAG, that is 0000. Turn on the OSDZU3-REF development platform by flipping the power switch. In Vitis GUI, go to Window, click on Show View. Under Xilinx, open Target Connections. Under Target Connections window, under Hardware Server, right click on Local and select Set as Default Target option. Right click on Local again and select View to open Target Connection Details. Click on Test Connection and verify if the connection was successful. Now that the OSDZU3-REF development platform is configured in JTAG mode, right click on PL LED Blinky project, select Run As and click on Launch Hardware. You should now be able to see Hello World displayed on the UART console. This validates our hardware JTAG setup. Now, let's configure our PL LED Blinky project to actually toggle the PL LEDs as originally intended. We can do this by replacing our current source code with PL LED Blinky.c file downloaded as part of OSDZU3 tutorial files from the Vitis tutorial on octavosystems.com. To do so, right click on the source folder of PL LED Blinky application project and select Import Sources. Browse for the OSDZU3 tutorial files _version 1 directory that was previously downloaded and then select Open. Under Import Sources window, select the checkbox corresponding to the file PL LED Blinky.c and click Finish. Delete the Hello World.c file under source folder by right clicking on it and selecting Delete. Open PL LED Blinky.c file. On line 52, change XPAR AXI GPIO1 device ID tag to XPAR AXI GPIO0 device ID because the PL LEDs are driven by AXI GPIO0 block in Vivado. Rebuild the PL LED Blinky project by right clicking on it and selecting Build Project. To run the application project on the board, right click on the project, select Run As and click on Launch Hardware. You should see all 8 PL LEDs blink periodically. Congratulations! You have successfully built and run the PL LED Blinky demo. Thank you and see you next time.